Okay, hello everybody. Thank you for tuning in. I'm Boris from Line, and today I'm super excited to be hosting Jacob, who is the product lead for Boundless at RISC Zero. Jacob, how are you doing? Welcome.
Doing good, man. I'm doing good. So finally getting some sunny weather in New York City, so can't complain. It's that magical 6 weeks where we actually get good weather here. And thanks for having me.
Yeah, it's a pleasure. We got to meet briefly in Denver, I think at the Boundless launch event, which was excellent. Huge shout out to your team for that. And yeah, you guys have had some big announcements lately. I guess we can just jump right into it. I mean, Boundless is your prover network, and you have some interesting mechanisms for getting people to generate proofs. And I'm excited to hear your take on it.
Yeah, so maybe I give a bit of background of where Boundless came from, like sort of how it came to be. Of course, everyone sort of knows RISC Zero for the zkVM. I think we're seeing the proliferation of RISC-V zkVMs, and that's becoming a standard, which we're really just happy for everyone to adopt and sort of grow the pie everywhere. What did the zkVM fundamentally do for people? Okay, you no longer have to write these abstract, confusing programs called circuits to use ZK technology. Now you can just use a high-level programming language like Rust. So much better development, right? Write Rust, generate ZKPs. About a year ago, a lot of people are interested. The performance is just like going absolutely exponential, like much faster. Exactly. Like it still surprises us today. We were looking at numbers internally the other day on like ETH block proving numbers, and we got to such a low value, like we had to go like double check in the back. Like there's no way this is true. And that trend is going to continue, but okay, we're getting better on the price and the latency, and that has to continue to get better. But what else was blocking people from adopting the ZK tech? So we went across, we talked to 10 teams at the beginning that were building on our tech stack. And we sort of found that they were all building the same thing. They were building the verifier contracts. They were building aggregation solutions. They were building ways to have sustainable proving. And that really signaled to us that we should be abstracting that away and lowering these go-to-market times and these barriers to adoption of the core ZK tech. And that's exactly what Boundless is. Boundless has a prover network. I would say it's much more than that. It's really aimed to take that next step. So we talked about the first one being, write Rust, generate ZKPs. Now I want you to write Rust and deploy production-ready ZK applications, and not just on one chain, but on any chain. So Boundless sort of abstracts all the necessary infrastructure to where now you just show up, you request a proof in a market. It's like 8 lines of code that you need to do to form your request, and we give you a bunch of tooling to do that request in an effective manner. And not only will the proof get generated, which tends to be the typical guarantee that prover networks will give you, we actually can guarantee delivery to your protocol. So just reducing complexity, even all the way to the proof being verified to your chain.
A lot of things I want to dig into there. Yeah, I mean, I'm completely with you on the need to make these tools more accessible to developers if we want people to build cool stuff with ZK. When you talk about delivery, and maybe we're getting ahead of ourselves here, and maybe you'll get into this later, but that's the one thing where I'm like, what do you mean by guaranteeing delivery and not just the proof generation?
Yeah, so typically in prover networks, you'll see different mechanisms that will incentivize a prover to make sure they generate the proof. This can be slashing, this can be consensus, this can be asking multiple people to do it, all these different mechanisms. To guarantee proof generation, we use like a slashable amount. But when a prover gets paid in Boundless, they're not just getting paid when they generate that proof. Typically as a protocol, I would need to go grab the proof from the prover network and then go verify it on a chain like Aligned or Ethereum. And that's just another step for failure. So we actually don't we don't pay the prover till they verified it on the chain the person wants it. And then once the proof is verified, we essentially have these like smart contract accounts for protocols where not only can they escrow funds and automatically request proofs in like a decentralized way, which is really nice for them. As that proof is verified, we can sort of do an automatic callback that automatically submits the proof into their market. So as long as you are accepting the transaction inclusion properties of the chain you're already settling to, which is sort of what you already do as sort of a roll-up or coprocessor or any of these sort of ZK use cases, the proof should actually be delivered to your protocol, and you don't have to worry about having another point of failure there.
Okay, cool. That's really interesting. So yeah, the operators, the network participants, the nodes that are running Boundless need to, like, everything needs to be settled before they get paid. That is interesting. So I want to go back to something else you said and ask about the entire deployment pipeline. That I want to ask about RISC Zero as well, just like the VM, but we can get to that later. Maybe it would have made more sense to start with that. But since we're already talking about Boundless, like, what was the deployment experience like for your users before this? Like, you mentioned a few things, actually running the zkVM somewhere to do the proving, generating the proofs, getting that center chain. You mentioned that people were writing their own verifiers. Like, I know there's verifier and Solidity for Ethereum, but I guess you meant like to deploy this to different chains.
Yeah. So, I mean, if we even go back like 18 months, we didn't even have a verifier contract on Ethereum. Right. So, and we're moving so fast, and that was the clear, obvious first thing to build, right? Was a set of verifier contracts, across a bunch of chains, so people could actually verify the proofs on chain and use them, which is quite a critical step. So there was that, but we saw a lot of people trying to build their own prover networks, and it's not something people want to do, right? Like, it's not a great value capture mechanism. It was just sort of a pain. Another one that you're going to be really familiar with is like doing their own aggregation solution, right? Like if we're trying to settle to Ethereum, settling a proof, it's not too expensive, right? It's like 270K gas for the Gross 16 we use, but you do that 1,000 times a day, like that can get quite expensive, right? That could become your most expensive. People are trying to build their own aggregation solutions. So we had some stuff in place, right? We did the verifier contracts for producing proofs. We've had Bonsai running for 18 months, and Bonsai is great. It's been great for testing, and we have like 3 to 4 partners in production using it today. And we have great track record of uptime and everything. But Bonsai isn't good enough, right? Like, we don't want to live in a world where people are having to come to us and do a handshake. Not only is this a hassle, but additionally, it's just more friction. Also, we think this open market has multiple benefits. One, we're not the only party anymore. Right off the bat, reliability. If we only need that one event of trust assumption in these ZK systems. If there's 100 provers online, which will be possible because we're practically open sourcing Bonsai for everyone to use. So now anyone will be able to spin up their own Bonsai. This can be sophisticated parties with data centers at low electricity costs. This can be normal people wanting to just mine and compete, right? Like early Bitcoin days. And this also can be protocols being their own backstop. It costs $0 to have this thing running in on-demand AWS until you need it. And additionally, we'll run a backstop. So it's just a lot of layers of redundancy here.
Yeah. And so Bonsai was like your original proof of service. So if somebody wanted to generate RISC Zero proofs, they could just run the Rust code on your servers, basically.
Exactly. They ping an API and we give them the proof.
Okay, cool.
So there's that. Additionally, we run Bonsai in like AWS. AWS isn't cheap. So allowing really large entities that have cheap electricity to be able to like connect to our applications. I mean, I think we might see just in that optimization alone a magnitude decrease in cost. And that's just our internal testing, right? Using a few GPUs in like the Northwest where electricity is not the cheapest. Additionally, we've sort of found recently, I was a little afraid maybe 6 months ago, right? The AI craze is happening. I think everyone has consolidated around ZK needing to be run on GPUs. And I was like, oh, wow, like AI is taking up so many GPUs. We recently sort of found out that for AI training, if you don't have the most recent, optimized chip for AI training, so think H200, H100, the 5090, you could still probably get away with using a 4090. Additionally, when you're doing that training, you need a really high connectivity to the person you're training with because you're transmitting so much data back and forth. So what has that created? What's created this glut of older hardware, such as 3090s, 4090s, in regions of the world where there's not prominent AI startups, China, Eastern Europe, Latin, Southern America, where you have a lot of big data centers and they have a lot of cheap electricity and they have a lot of these older machines. A great example is like Ethereum Proof-of-Work miners.
Yeah.
So we talked to one guy, he's in like Puerto Rico. He's got like 10K GPUs. But they're all 3090s. But what else is he going to use them for? So we're sort of tapping into this really like deep liquidity of provers that work great on our system. That's what we've optimized for, that sort of consumer grade hardware from the beginning. And we're going to make that accessible to everyone, which again, right, gives us better redundancy, gives you, the user, better cost. Just creating a better product for people to deploy on.
Yeah, I mean, and you guys have done a lot of work around making ZK cheaper and faster with zkVM, right? So it's kind of cool to see. At least I think it's cool to see. There's like the VM itself, which is getting faster, and then there's like how the VM is even used, where it's being run, and that's all kind of like bringing us to a place where many more people can use ZK, which is also, it's been our focus with the line as well. Like, let's make verification cheap because ZK is getting cheap and lots of people are going to want to use it. But Ethereum, verification can be expensive.
Yeah. I sort of, I've been drawing this parallel recently between, we sort of, this is one of sort of our big, like, I think, contributions with the white paper is realizing that ZK proving is a commodity. And then, okay, we introduced Proof-of-Verifiable-Work, which we can talk in a sec, but just understanding that verifiable compute is a commodity. Commodities tend to go through the same cycle of market sophistication. So the most famous example is oil. Oil used to be these localized regional markets that don't talk to one another. All the agreements are handshakes. There's not an open market. You're sort of just getting a price from a vendor. There's no debate or competition. And in hindsight, that's really bad. There's market manipulation. There's price fixing. There's not competition. There's unreliability. What happens if your vendor goes out? Like all these things. And that's where ZK proving an infrastructure sort of lies today. You don't have many options and whatnot. With Boundless, we think not only are we skipping the era of like industrialization that oil went through in like the early 1900s, and you sort of had the verticalization or vertical monopolization, right, by like Standard Oil, which had some benefits to users but ended up being quite predatory. We go straight to modern markets. So we introduce like futures and spot markets to be able to just have better long-term planning. And have it be open and competitive, which, in the history of commodity markets, if you have a capitalistic market and you don't induce these sort of additional parameters, always ends up benefiting the user.
Very, very interesting parallels. I feel like it'd be worth talking about parallels to like cloud compute in general. Because that's something I've been interested in. Like, I haven't looked into it too deeply, but I think you must have, right? Like, why haven't we seen something like a one-stop interface? I think I know the answer. It's probably just like engineering issues. Maybe like
we
could provide a nice, like very defined like boundary of what kind of workloads need to be done. But it's like, you know, there's a bunch of different cloud providers, right? AWS, GCP, etc. And you know, I
Yeah,
can
I
imagine
mean,
just like route whatever they're trying to run to wherever needs to be run, but maybe that doesn't make sense in that context, but does for zkVMs.
yeah, I mean, so RISC Zero is based in Seattle, so Cloud City, right? You've got AWS, Azure, GCP, all there. The team is very familiar, a lot of ex-Amazon folks on it, with how AWS functions. And we see, I mean, it is an analogy. Analogies always break down, right? But it is an analogy that we use internally at times to compare AWS to Boundless. Of course, we want to be more permissionless and not host that, but we want that, right? Like we want people to show them and have this one-click experience. Also, we can learn lessons from AWS. You compare on-demand reserve pricing on AWS. It tends to be a 5 to 6x just for someone to be able to have that ability to plan long-term, right? And with the original, with the, you know, market will go to mainnet with pretty soon with Boundless, it is going to be on demand, right? It's a spot market. But that reserved pricing is really what we unlock with Proof-of-Verifiable-Work, where people sort of have this better long-term planning. And you talk to data centers, like they're going to much prefer this. Also, it's going to be great for applications. You know, some partners have brought up the concern that, well, how do I know a prover remains online? And we have, you know, some mechanisms and backstops for that, but they're going to really enjoy being able to reserve a certain amount of capacity for a week, 2 weeks, even a month at a time. Just knowing that you know, if I'm a rollup, that prover is dedicated to me, they have a large financial incentive to deliver these proofs. And even if they fail, we have these backstops to make sure they get their proofs on time.
There's a car horn honking outside. I don't know if it's coming through on my on my microphone, so I'm just muting myself strategically. Yeah. Okay. So I think this is. I mean, I want to talk about a few things. Like I want to talk about applications that use ZK. We can get to that after. Maybe that's a good way to close. Of course, I want to talk about RISC Zero. But since we're talking about Boundless and proof of verifiable work, I think that's where we should go next. Like you mentioned, the spot markets. Like me right now, I need a proof generated. I have a program I want to run. There is, you know, this reverse Dutch auction that you guys use, but that's not where it stops, right? Like you're trying to normalize or kind of even out the demand and allow people to you know, run their infra with some certainty. So how do you do that? Like what kind of financial engineering, I don't know if you want to call it that, are you using?
Yeah. So I think maybe we quickly go over like the 3 contributions we sort of lay out and with the white paper released last week. So one is sort of this infrastructure that we've talked about, right? Like a full stack solution to be able to deploy applications more easily, and an easy flow for that actually to be done in a robust and decentralized manner. I think I'm super proud that from day one, Boundless will be decentralized. If RISC Zero or any other dev code contributing to Boundless ceases to exist on day 2, it will all still work. And it can advance and progress and become this lively ecosystem. We really don't have any like backstops or multi-sigs like that. And when you're securing billions of dollars, that's how you have to be. There's no reason to, or there's no way we can sort of like cut corners there. So there's that. The second, you know, contribution is this realization that ZK proving is a commodity. And with that, we create proof of verifiable work, because with any commodity, we need an objective way to metric that commodity. So you think of like oil, or not oil, gasoline, it's ethanol content. We all go to the gas pump, we see 86, 87, 88, 89, 91. I don't know what type of car you have. I don't have a nice enough car to justify 91. You look at you know, grain, it's protein content. So, right, if you have a low protein content, it goes to animal feed. If you have a high protein content, your grain goes to make beautiful pasta. With ZK, since we finally have this general purpose platform, we've actually had this sort of notion of how much work we've done in this thing we call cycles in the RISC-V zkVM, which you can think of as instruction steps in RISC-V. There is quite a bit of nuance here on how to make sure that this metric is not gamed. And from a performance engineering perspective, we've been very careful to not neglect this notion of cycles in our zkVM, which I think is quite unique. But additionally, when we introduce Proof-of-Verifiable-Work efficiently into the zkVM, people will be able to sort of see how we can manage DOS attacks here and there, because there's a few you got to be careful of. But what we generate with Proof-of-Verifiable-Work is sort of a cryptographic proof of how much work the prover's actually done. And you can think of it just sort of as an additional receipt to the already succinct receipt we exit out of zkVM. But now we have this objective metric. And when you have an objective metric, right, we can attribute to how much work people have done after the fact. So this sort of plays into two parts of Boundless. One is we need to bootstrap provers to a certain known level scale of economy where we know we're going to hit sustained cost drops. We've sort of been in this tension of this industry recently of there's not an insane amount of demand, but also people need cheaper costs, and cheaper costs come from better hardware. So incentivizing that investment up front for these provers will be huge. And once they hit these sort of like scales of economy, it'll benefit the application. So we can use this token essentially to bootstrap that adoption by incentivizing not only cheaper proving for these applications to come online faster, but this additional reward before that demand is really there. And additionally is these long-term agreements. I can sort of set up a contract on chain now to where I want this type of proof. I'm a roll-up. I want to prove my EVM blocks, right? And then I'm willing to pay Y price per mega cycle or something. And the prover can just get the inputs, generate the proof, and then just constantly submit these receipts to the contract to sort of retroactively get paid for the work. So very typical to, right, like an oils futures contract, to where I'm an airline business, I'm trying to hedge my cost, right? And I'm okay with this oil price. Predictability is always what you want in a business. And you want to protect yourself against, right, volatility in the market. So now we can sort of lock people in there as well. And, we see all the additional efficiency benefits you see just in traditional businesses now with zk proving as well.
Okay, very cool, very cool. Yeah, the proof of verifiable work, like the proof of how much proving work was done, right? Like how many cycles were used. That is super interesting. I admittedly have not looked into it in much detail, but I did sort of like skim through it, and I was like, oh, this is really cool. Is there information on like the actual engineering there for people who are curious? And like, could you? I'm not an engineer. I've written a little bit of code, but it's not my trade, let's say. And it sounds very cool, right? And like obviously you've had to think a lot about how to build this so that way a prover running Boundless can't lie about how much work they did. Like they'll generate the correct proof gets verified, but then they say, oh, like, I used way more electricity or way more cycles than was needed, so they can get like a bigger reward.
There's
the sort of like, I don't know, high level of that.
Yeah, there's no public information yet. We're like doing the implementation right now. So figured out all the details and whatnot. But we'll release it when it's ready, and of course we'll be testing that on testnet before we sort of launch it into the wild.
Yeah, of course. Cool. Yeah, I mean, this brings me to, well, I'm going to ask you about where Boundless is at today, like testnet wise, if you have different phases for people who are interested in participating in different capacities. But before that, actually, like since we're talking about this proof of verifiable work, and I'm sorry if this is like a spicy question, but like, would it be possible in the future for Boundless to support a different zkVM? Like say there's zkVM that is just getting more adoption than RISC Zero, but you have this great market and network that can generate proofs. Is that something you've thought about? Feel free to not answer the question. I don't want to put you on the spot, but it came to mind.
No, this is a great one, and this was one of our like first principles when developing the protocol, even 12 months ago. Is when you look at where zkVMs are today, it's very reminiscent of the chip architecture wars in the late 80s, essentially. And in the 80s, there was 20, chip architectures. No one knew who was going to win. And I think when we look at RISC-V zkVMs, of course, we're big fans of the RISC Zero VM, and we think we're ahead of the game right now and whatnot. But there's other very interesting things to go on. And the reality is that there's no way a zkVM is going to be complete winner take all here. There's going to be zkVMs that are better at client-side proving. There's going to be zkVMs that are better at proving EVM blocks. There's going to be zkVMs that are better at doing other things, right? And we want to de-risk there. And we're going to support a lot of zkVMs. We can add this functionality to more. I think in the near term, we could see that we support more zkVMs. There's a lot of great teams out there doing improvements, getting adoption. I'll also I talk about applications not wanting to build this infrastructure. zkVM teams don't want to build this infrastructure. Right? Yeah. For value accrual in this space, you either go up or down from the zk tech. There's no really value accrual there. Some zkVM teams are not interested in building this, and we'll be working with them shortly. So maybe you'll see an announcement here or there in the next quarter or two. So yeah, it's completely zkVM agnostic. I don't understand how one person could bet their whole network on a single zkVM now. So much in the air. There's so much happening. So we want to help everybody, essentially. We want to be the home of zk.
That makes a lot of sense. I really like that. I don't know if that's been explicitly communicated in any of your content or materials, but I was thinking it would make sense to not limit yourself. You got to be boundless. Don't bound yourself, right?
Exactly.
And happy too, because they can get more users who want maybe a different zkVM, which is optimized for other tasks.
Yeah, I mean, any market comes down to volume and liquidity. If you want liquidity, which in our case is proving, you need massive amounts of volume, and we can get this really nice network effect to where once we sort of aggregate this demand, then we'll have the best provers, and then it will just be a snowball that really benefits all of these ecosystems.
Yeah, well, so we're talking about a decentralized network of provers, and I don't remember if I saw this in the white paper, but is there some consensus mechanism that's sort of running in the background to coordinate everything and ensure that all the provers are being honest? I saw slashing mentioned in the white paper, but I didn't get to do a deep read, so I wasn't sure how that was going to work, but I'm really curious.
Yeah, so with any sort of dispute, we sort of inherit the dispute properties and settlement properties, just whatever blockchain you already choose as your settlement. We don't have a consensus mechanism. You think of proof of work and proof of stake. There's sort of these rules that help disputes settle out when bad actors appear in consensus-based mechanisms. With proof of verifiable work, it is also a Sybil resistant mechanism, but it's really optimized for zk. Because when you think about traditional consensus mechanisms, some are 51% attacks, but really most of the proof of stake ones, if 33% of the actors are 33% plus one, right, end up being bad, not only is your liveness going to get killed, but safety, right? Funds are at risk at that moment. So I think when we think of decentralized, right, people are normally thinking of that metric. With zk, as long as you assume that the zk circuit is secure, the trust assumption is one event. So we don't really need to communicate to other people. We just need to make sure that people are able to access one another or access the same bids. And if we make that really accessible, then we should be good to go, which we sort of think we're doing, right? We're open sourcing Bonsai. We're bringing on very sophisticated parties. We're making it even accessible to normal people like me and you if you have a gaming laptop. So yeah, we don't need to do that peer-to-peer overhead communication. There might be some in the future when we start to think about what is possibly native aggregation could look like. If I'm a prover, like I have the financial incentive to talk to other provers to aggregate our proofs. Also, we have the incentive to talk to someone like Aligned or aggregation solution to send the proofs to save money, right? Because if I'm saving money, I'm bidding lower on the market. I'm happy because users are saving money.
Yeah, that makes sense. I guess you mentioned like the nodes need to have access to the same bit. So is there some kind of like DA layer built into the protocol that ensures whatever people want proven is available for whoever?
Yeah, so you need the inputs for the proof, right? And we offer multiple solutions here. One, you can use call data of the settlement chain.
Mhm.
In some cases where this is an L2 or an Alt L1, this is totally economically feasible.
Yeah.
Also, when we sort of think about Boundless, we want a happy path that's really cheap, and we want to make sure we have a fully decentralized sad path. And that call data is that fully decentralized. We also offer, a Boundless Devco, which is currently RISC Zero, right? Offers an off-chain solution where you submit to us, we have all the provers connect to us, and we can broadcast requests and all of the necessary inputs. You can use an IPFS link where if you're hosting it, that it's going to be ready. It's pretty simple to host an IPFS link. Additionally, you can use something like S3 buckets and all this. We also have the solution to use alternative DA solutions like Celestia or like an EigenDA. So we really want to offer the spectrum of like, what do you want as a user? Clearly explain the trade-offs, and of course make sure we have that fully decentralized fallback option to where when things do go bad or you have someone grieving. The other point there is for someone to like realize they can bid on these bids, they simply just have to run an RPC for the chain and listen for events. Since we're just the conduit really is just a set of smart contracts on all these different settlement chains. You as a prover just hook up to the chains, right? You can use a third party. Like if you're Alchemy, you can run your own node. Again, there's sort of that customizability option. A lot of the provers, of course, are already running their own node on these chains. There's these sophisticated, proof of stake validators and whatnot. So so it allows everyone to sort of connect.
No, I like that design philosophy, if you want to call it that. I think we at Aligned feel very much the same way. Like we want to provide a solution that works out of the box, but give users the flexibility to, approach things differently or use their own services. With our fast mode AVS, we run a batcher, but you could run your own batcher if you wanted. You don't need to use our batcher. Smart contracts are there. You can still use all the eigenlayer operators. It's like, and I think that's important personally. It's you can't lock people in, or else they're gonna have to think a lot about their choice right away, right? So yeah, that's cool. I want to move on and have some time to talk about the RISC Zero VM a little bit.
Mm-hmm.
But you also mentioned something like 12 months ago, when you didn't necessarily say this, but I'm curious, like how long have you been working on Boundless? I mean, Bonsai has been live for 18 months, you said. The RISC Zero VM has been in development for several years, right? What is, and this is me just, I'm curious, like what is the development timeline look like for Boundless? Because I imagine you've been thinking about a lot of these issues for a long time, but like, what was it like, okay, we're doing this?
Yeah, so, right, the motivating question of Boundless, which was what is stopping people from deploying from production, right? We're a very product-driven organization at RISC Zero. We're here to solve problems for users, and we're not going to just do something to do something, right? Every single thing we do is because some user asked for it. It's a hard requirement when we propose things internally. It's like, who is asking for this, right? Mm-hmm. I joined RISC Zero about exactly 1 year ago. And when I joined, Boundless was exiting its sort of design experimentation. So the team had tried, okay, we want to do this thing. We want to make deployment better, right? So Boundless had tried, what does this look like if we do our own L1? What does this look like if we do, out of box L2, custom L2. We looked at a plasma, we looked at Validiums, we looked at every single solution. And that's when we looked at what the user needed, how we ended up on this smart contract solution. So that's about a year. That's probably the total time of the project. So we've been working on it for about 12 months. It's been my main project at the company the whole time I've been here.
Yep.
And yeah, hopefully we can get some mainnet with real funds quite soon. So
Yeah,
quite a crazy
it's
timeline, but
a year, and you have like, is testnet fully live now, or devnet, or like, what's the status? I think people are dying to know like how they can participate and how they can use it.
yeah. So if you're a developer, we're live on testnet, we're live on Sepolia, all the documentation is ready to go. I wouldn't expect the interfaces to change too much. You can start building today. The zkVM is fully production ready, whatnot. If you are just someone interested getting involved in the ecosystem, we launched our Discord last week. Pretty cool. We already have over like 200,000 members of the Discord, which is pretty bonkers numbers to see that grow so fast. And shout out to sort of our community team on really making people feel at home there. You can go there, get involved in the ecosystem, right? We have like over 30 partners committed to production. You can see, I think we want our community to experience the future of ZK. We don't want to just talk about it. So instead of, having someone go play a game or whatnot, I want you to go experience what's out there right now and understand that ZK is the future for applications. And then if you're a prover, proving is currently permissioned. So there's a form you can fill out. If you're like a sophisticated party, we're sort of doing testing and getting things all stable there. The next phase we're pushing to is real funds. So it'll still be like testnet or mainnet beta, whatever you want to call it. But it will be with real funds. It'll be real proofs. Partners will start moving over. Proving will be completely permissionless for anyone to participate. And then again, we're going to be focused not only on providing people the opportunity to sort of experience what the future is with our partners that are already live with ZK, but be able to contribute to like sort of a greater good, which I'm really excited for, not only for our testnet or our mainnet beta to actually be, straining the network, but for people to really contribute something that's just going to make the whole ecosystem better.
Super, super exciting stuff. Thank you, Jacob. Yeah, where to? I don't want to keep you too long, but I think I really do want to ask you about the RISC Zero VM. Like the heart, the engine generates these proofs that Boundless is letting people generate for cheap, or will let people generate for very cheap. So we've been talking a little bit about the RISC Zero VM at Aligned. For people who are maybe tuning in from like the Boundless or RISC Zero side, our first product is an eigenlayer AVS, our proof verification layer. We support the verifier for RISC Zero, among other proof systems and some other zkVMs. So you can verify these proofs on Ethereum really cheaply. We've been following the zkVM space really closely and doing benchmarks. We have a zkbenchmarks.com website where we are publishing all this open source to look at the performance of different zkVMs for different workloads. And the reason we were doing that is because of our second product, which we have on testnet now, and we actually will be making an announcement about this. We put the testnet version out, the sort of alpha MVP, initially aggregating SP1 proofs using the SP1 zkVM, and just yesterday we finished the integration for the RISC Zero VM. And RJ, one of our co-founders, he tweeted about it. If you're in our Telegram group, he shared some demo stuff, but we're going to be putting together a full thread here. And basically that means you can aggregate RISC Zero proofs using the RISC Zero VM. We run this aggregator, and just like our first product, you can verify these on Ethereum for much cheaper. And we think this would be really useful for things like rollups, high-value applications, and of course, our own rollup stack, which we just announced, which is in development. My understanding is we will be using RISC Zero for that as well. So that's why I want to maybe have you share a little bit more about the RISC Zero VM. People are probably familiar with it, but for anyone not, just like a intro to this, like what is it? Why do we care? I know why, but yeah.
Yeah, so you're right. We're working on R0 VM, which we recently renamed. It was just like RISC Zero ZKVM. It's sort of a mouthful.
Yeah. Yeah.
R0 VM. I think two things to get really excited about in the near term future. Well, I guess three things. One is our formal verification work. So we recently released a tool called PICUS. These systems are new. You got to treat them like they're critical security infrastructure. So we're actually getting to the point to where we can sort of say we're free of under-constrained bugs, which is really huge because this is 99% of what soundness bugs come from. So, just continue to secure things. The second thing is the Benius work, which is coming along quite nicely. Benius is sort of the end game for proof systems, and we could see potentially a 30x speed up from our current numbers, which is quite bonkers.
That's just like based on new types of cryptography to do ZK.
Exactly. I highly recommend going to check out I highly recommend going to check out the Benius paper from the Irreducible folks. They're fantastic. And the last thing is real-time proving. That's sort of the other edge of performance right now, and we think we can get there in the middle of the year. So proving an ETH block under 12 seconds to unlock asynchronous composability between rollups.
That's amazing. Yeah. I was on the ETH proofs call last week, and Jeremy was there giving an update, and he said real-time proving by July. So let's go. We're very excited for that as well. Cool. And yeah, like I don't know if there's any backstory. Like I guess you joined about a year ago, but the RISC Zero VM has been in development for a long time, and I know the folks I work with really admire the engineering work. Like, do you have any, thoughts on how it's evolved, or if there's been like any major design changes, maybe in the context of Boundless, or?
Boris, could you just give me 1 second? Someone's like banging on my door.
Oh.
BRB.
Yeah. Hello, everyone tuning in. Build the noise. I hope you're enjoying this chat. I'll add in these sort of like little closing thoughts right now. We're doing these every week because I, like learning about other cool stuff in the ecosystem, and we like sharing all this cool tech with our community. So if you do have like feedback or guests you'd like to see, or topics that you'd like me or the rest of the team to cover, whether for this or other content, please feel free to just let me know in Discord or Telegram. I hope these are useful. I definitely learned a lot, and I've really enjoyed this chance to hear from Jacob today. We're probably going to wrap the stream up in a second. I'll just wait for him to get back. Yeah, in the meantime, if anybody is curious about the aggregation service, our second product, you can look at RJ's Twitter and also ours later today, where we talk about this update and this implementation or integration of R0 VM. We're really excited for that. If this is something you're using, feel free to reach out to us. Okay, Jake, you're back. I was just filling the air and talking about some other stuff and being like, if you guys have feedback, comments, different guests want, let me know. But yeah,
sorry about that.
No, it's all good. I know it happens. Yeah. Well, anyway, I don't want to keep you too long. RISC Zero VM, super cool stuff. We're hoping that we can also help more people use this on Ethereum. I am excited to keep following everything that's happening with Boundless. You guys have been doing some very cool work. Love the comms and like promotion around it. Great stuff. Shout out to Reka. Yeah, very, I feel very aligned about this whole idea of just bringing ZK to more developers, so more cool apps can be built. I think if I start asking you about, use cases of ZK beyond the obvious, like rollups and scaling, blockchains and identity apps, we could be here for too long. So I think maybe I'll wrap it up here. And do you have any sort of like closing things?
Yeah, I mean, I think at Boundless, we're super excited to work with people like Aligned and just the broader ZK ecosystem to grow the pie. We want to work with all these ZK teams. We want to make ZK accessible to everyone. I think for far too long, it's been inaccessible. It's required tens of millions, if not $100 million in funding to launch something. And that just can't be the case if we're going to go for mass adoption, right? We've seen these typical use cases around rollups and co-processors, and all of that has required just so much time and effort and funding to get off the ground. I want people to spin up applications like they do on AWS today. And I think that really gets us to adoption, because ZK is this just fundamentally directionally correct technology, right? You know, most people know it for like privacy and whatnot, but we're finally seeing people get to expressivity levels, is what I sort of call it, because I just hate the notion of TPS. But just expressive applications, right? Now that we can do this sort of boundless computation, which is, yes, where the name Boundless comes from.
Yeah.
So I'm just super excited. How do we make this more accessible to people? That's always my mission as a product person. Want to be solving people for users, and my users are those app devs that are really going to bring ZK into mainstream, not just in, you know, Web3, which is a lot of our customers right now, but building apps that blur the lines between Web3 and Web2, and we sort of get this nice, you know, verifiable property across applications, which can just make them more efficient, more secure, and hopefully brings, you know, that mass adoption everyone always preaches about in the space.
Dude, totally on board with you. Like, you know, I really love working in an industry with like folks like you and your team and others who are like building the sort of broadband for verifiable computation, because we also feel like ZK and verifiable compute are like beyond blockchains. It is going to be the future, and that's why we're building the things we're building. So we think this infra will be important for, you know, apps we haven't even thought of yet. I vibe coded a little Flappy Bird game in Rust because I was like, can I make like a game in Rust? Like, I don't, you know, maybe have a verifiable leaderboard. I didn't try running it in a zkVM, but like, if you're watching this and you're experimenting, give it a shot. Try making some like fun little Rust apps that could be verifiable. And
yeah,
that,
I mean,
yeah,
when we think about the internet and how we've progressed, right? We went from HTTP to HTTPS. I mean, a lot of the properties these security people want, like, could end up being HTTP ZK.
Yeah.
There's a lot of nice properties. The security of the internet is always evolving. ZK is going to go much, much farther beyond just Web 2.
Totally with you on that. And like making it cheap.
Sorry.
Yeah. Making it cheap, faster and easier to use is like a big part of that. But like, you know, we couldn't have had YouTube if broadband internet didn't exist. So
exactly.
Yeah.
This is where I'm like such a huge fan of like the work that like Maiden, Valida, Aztec are doing around like client side proving. We're also quite interested in client side proving, right? We've generated a proof on an iPhone before, which is pretty cool.
Nice. Didn't melt.
No, actually it generated, we got to generate, this was back in like July of last year also. So, right, like the performance has like, you know, crazy improvements since then. But since July, or in July, we actually generated a proof of like a valid RSA signature in ZK. So like fully ZK as well. So pretty cool, right? Yeah. There's definitely some, like, that's like a real proof.
Yeah.
On a thing. So
that's awesome. That's awesome. Well, I'm sure there's going to be a lot of exciting stuff to talk about in the future. I'd love to have you on again. And yeah, to everyone who tuned in, thank you for watching. This is going to be on YouTube. If you know, you want to share it with friends, we'll be posting that on Twitter. And yeah, Jacob, once again, thank you so much. This was super fun for me, and hope you have a good rest of your day.
Yeah, amazing, man. Thanks for having me. Best of luck. Excited to, you know, just make ZK cool again.
Let's go.
All right, bye-bye, man.